And it is recording. And we are going to pick up at the systematic random sample. There it is, systematic random sample. And we said that systematic random sample is picking every fifth person, okay? Technically, it's not a random sample because if Miss Hatton is the sixth person, then she don't have the same chance as every seventh person. So that's why I don't like to call it a systematic random sample, because it's not random. It's kind of an oxymoron or a paradox if you say systematic and random, because they're kind of opposite of each other. So, but in a situation where you have thousands of people to survey or to ask a question, systematic is the best way to go. Ask every 10th person that comes out of the building. Okay. Survey every 10th person in the classroom, or every fifth person in the classroom. It's a way to get a general census of the population or the sample that you're trying to get. Okay. So I would say this is probably the third best sample. Random is the best. Simple random, which is putting you into groups, is the second best. And this would be the third. A cluster sample. Cluster sample, I'll tell you the best example of a cluster sample would be a voting precinct. Okay. I vote at McLeese School. Okay. Now, if you're from around here, it's called McLeese because Henry McLeese was the person that built the first school in this community, and his name said his name McLeese. But of course, the people around here know more than the people that grew up here, and they call it McLeese. So I've been pronouncing it wrong for the last 50-something years, and my father, he pronounced it wrong for 50-something years. It's McLeese. So I vote at McLeese, and McLeese Elementary School is a voting precinct, and that would be a cluster, okay, because you have a bunch of people in a geographic place meeting there in one day, which is November 3rd. So if I wanted to be a statistics person, I would go out there and stand on the sidewalk, and I'd say, I'm doing a survey. Would you mind telling me who you voted for president? And then I would ask them Smith or Jones. And then I would say, Republican or Democrat? Are you a registered Republican? Are you a registered Democrat? Or are you just a person that votes? Okay, meaning that you're not a card carrying member. I'm not a card carrying member of either party. Okay. So there's a lot of people out there that's not a member of a certain party. And you would ask those questions. That would be a cluster sample. Okay. Because everybody in that building at McLeese Elementary School lives in the same area. Does everybody understand that? Hopefully you do. Cluster samples are good. Usually an exit poll. You're going to hear on November 3rd during the election, you're going to hear about exit polls. Exit polls kind of solidify what the voting is doing. Let me give you an example. If you are doing an exit poll at a voting precinct and you set one up at each voting precinct in every county in South Carolina, and the assignment is to ask 100 people out of each precinct, out of each county, who they voted for. And then you take that, tally it up, and you can pretty much predict what person is going to win the election for that state if you interview 100 people out of each precinct, out of each county. Now you're talking about a lot of exit polls. But you could actually determine for that state who is going to win based on those exit polls. And that's how they confirm a lot of elections before the ballots come in. Stratified, divided in population by gender or race or religion or income. Okay, so let's say I go to that voting precinct and I set up another table and I set up Miss other table and she asked how many people, who did you vote for? And she writes down if they're male or female. That would be a stratified sampling. Stratified means gender, race, religion, or income. Okay. Convenience. Why do they list convenience last? Because it is the least accurate and can be biased. Let's say Miss Hatton works at a radio station and she is the DJ for the radio station. And she plays nothing but 80s rock. Okay? That's all she plays. That's her show. She's on the radio for 3 hours and she plays nothing but 80s rock.
That's what I want to listen to.
What?
That's the station I want to listen to.
I know, that's the station I listen to. 80s on the 8s, or what's it called? 80s on the 8s or something like that. That's what I listen to. And she has a math teacher that tells her she needs to do a project. And she says, well, I don't know what I'm going to do a project on. And she gets on the air and she says, look, guys, I got to do a project. And I want to know how many of you out there, I'm going to take 100 callers and I'm going to write down what music you like. Okay, what's wrong with that picture? That means I want y'all to answer it. What's wrong with Miss Hatton announcing on her radio show that she wants 100 people to call in and tell her what kind of music they like?
They're probably going to have all basically the same answer.
Why?
Because it's a very specific station, and then
exactly,
we'll
and everybody's listening to her show, and she plays 80s rock. So what is every single one of those people going to say?
They're going to say 80s rock.
They're going to say 80s rock. All right, that is an example of a convenient sample. All right, it's kind of extreme, but it gets the point across. All right, you know, there's an old saying that says nothing is free. And then there's another saying that says you get out of it what you put into it. Now, both of those kind of play in with a convenient sample. All right. If something is easy, chances are it's not going to help you very much. Okay. Just say it. If you use a convenient sample, don't be surprised if your data is a little bit skewed. Okay? Now, why do I show you these? Because these are good test questions, and they're also always going to be on a standardized test. A random sample, systematic, cluster, and stratified, and convenience. Okay, I'm not going to go through the examples because I think y'all, well, every 20th. When you see every TH or every ND, like every second or every fifth, you know it's systematic. A $50 gift certificate is given away at the annual Bankers Convention. Tickets are placed in a bin and the tickets are mixed up. Then the winning ticket is selected by a blindfolded person. That's a random sample. Equal chance. Every blank, systematic. Even chance. Every person has an even chance. That's random. Children in a large city are classified based on the neighborhood school they attend. Neighborhood school they attend. Sounds like a cluster to me. A random sample of 5 schools is selected. All the children from each select school are included. That sounds like a cluster because it's geographic. Keyword, geographic. So you should be writing down every blank systematic. Everybody has the same equal chance. Random. Geographic cluster. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. The first 50 people. Sounds like convenience. Let me ask you a question. If you're at Six Flags, or if you're at Disney World, or if you're at a zoo, and the gates open, who's going to be the first people running through the gates? Y'all not hearing me or what?
Your children.
Children, exactly. So that's not a very accurate first 50 people. Now, what if I said the first 50 adults? Then that would be different. But the first 50 people, that could be kids or teenagers. And hell, you don't know what's going on until you start paying taxes. Then you can just, then you know what's going on. Shut up, Hubert. Shut up. Just keep going. Shut up. I'm going to keep going. All registered vehicles in the state of California are classified according to, what does that say? Type. Type stratified. So you write down type equals stratified. That could be male or female. It could be SUV or midsize. It could be black or white, yellow or brown. It could be, I don't forget what else. It could be blondes, brunettes, redheads. It could be anything, but it's a what? A type, stratified. We talked about this earlier, and I brought in the word bias, okay? That's what this is. Many individuals, businesses, and advertising firms, we need to put in their news outlets. Many individuals, businesses, and news outlets misuse statistics to their what? Own advantage, and that's called bias. You have to make sure that what you're looking at makes sense. Was the sample used to gather the statistical unbiased, there's that word, and of sufficient size? Now, I want to make it perfectly clear. I'm not talking about bias so much because it's an election season, okay? Anytime you're teaching a probability and statistics course, that word right there, as well as neutrality, has to be preached. It has to, because when you're doing any of statistical analysis, you have to be down the middle. You have to. Is the statistical statement ambiguous? Could it be interpreted in more than one way? 4 out of 5 dentists recommend sugarless gum. But how do you know there's not 100 dentists? We could have just picked 5 and said, do you like this gum? And 4 of them said yes. Then you could say 4 out of 5. But there was 100 in the group. Yeah. Okay. Let's say that I have went across the United States and I surveyed across the United States and I have found out that Benjamin Smith is going to be the next president of the United States. Okay. I have to make up names because if I don't make up names, oh my God, I would have 15 people email my department head saying that I'm for this person or this person. Okay, so I have to make up names. Benjamin Smith is going to be the next president of the United States. And I go through and I show you that I went through South Carolina, Georgia, Alabama, Mississippi, Louisiana, Texas, Arizona, Nevada, and California. Did I go across the United States? Yes or no? Okay, that's a simple question. Yes or no? Do y'all not know geography or what? Did I go across the United States?
No.
Okay, y'all's icons are lighting up, but nothing's coming out. Did I go across the United States going through South Carolina, Georgia, Mississippi, Alabama, Louisiana, Texas, Arizona, Nevada, and California? Did I go across the United States?
Yes.
Yes. Yeah.
Yes. But what did I go through? Y'all ever watched my cousin Vinny? I went through the South. Oh, forget it. Just forget it. Just forget it.
Everybody had a brain fart.
No, I think y'all are on drugs. Okay? So, in an advertisement for golf balls, a driver golf ball is hit and another brand of golf ball is hit in the same manner. We are told that driver golf balls travel farther. Now, the only way to conduct an experiment like this is to have a robot that actually does the same identical swing every single time, and the ball is set at the same place every single time, and that's the only way to tell if a ball is drove further than another ball. Okay? Y'all ever seen that commercial? Y'all ever seen that video on Facebook? Robot bowling. Y'all ever see that? Robot bowling. Have y'all seen that?
No.
No.
Okay. Now, is that a way to test bowling balls? Yes. Why is it a way to test bowling balls? Because that robot is going to do the same thing. Now, I would set it. Okay, I wouldn't set it to where it would hit the, pins in midair, but you would set it to where it would roll the ball every single time the same way. And no reaction whatsoever.
That's pretty neat, though. That's
yeah,
my first time
well,
seeing it.
that's good. Okay, good. I'm glad you acknowledged that you looked at the video. Thank you. All right. So basically, what that means is when you're doing a survey or whatever, or if you're doing something like this, you don't put a person hitting the ball. Corona. You have some kind of robot that hits the ball every single time the same way. Then you can say this ball outdoes this ball. Okay.
I thought the driver was a club.
Yeah, well, they were talking about, okay, same thing. You would have to put the driver, you would have to have 2 robots that are made the same way, or put the club in the robot and then do 10 balls and use the same balls with another driver, put it in the robot, and then try it that way. And you would have to measure, you would have to put the club in the robot's hands at the same measurements. Everything has to be what? The same. And then you could tell whether the driver, I thought they were talking about golf balls. Yeah, it is. The driver golf ball is a better golf ball. Yeah, they call the balls driver, okay? But anyway, whether you're doing the ball or whether you're doing the driver, it doesn't matter. Everything has to be done the same. Same thing with surveys, okay? You can't go out here and say, you know, do a survey and ask people that are not in favor of the survey and not ask people that are in favor of the survey. You can't do that. That's not right. It's just like going out and, you know, having these polls and going out and asking 75% of one party, who do you want to be president? And only 25% is in the other party. And then you're going to get all these polls that say this person's going to win the election. Well, those are leading polls. Those polls are not right. So, but we wouldn't see that in America, would we? Then that's what they're saying right there. Possible sources. No 2 swings are identical. So you would have to make the 2 swings identical. And the only way to do that is to have it done by machine and have the settings exact. You can't, the only way you could do this is to have it done in a building where there is no wind. And the ball would have to land on a similar surface. So it would have to be the same surface, whether it be grass or dirt or whatever. Vague or ambiguous words. Average. At least. I'm not going to spend a lot of time on that one. I'm going to move on down to more important things. Daggone. Charts and graphs can be misleading. Here is the same graph. What is the problem? Look at the 2 graphs. Give y'all a second to look at them. What is wrong with the graphs? The graph on the left is correct. The graph on the right has been manipulated. See this little thing right here? They took out a good portion. They took out 0 through 25. They just took it out. You can't do that. What's wrong with this one? They took it out. They took out 0 through 95 right there. I'm going to give you an example of something that happened in 2016. The Republican nomination. Y'all remember last year or 2016, the Republican nomination? There was like 15 people running for the Republican nomination for president. And everybody said that Jeb Bush was going to be the president. Everybody said Jeb Bush was going to be it. And of course, the first 5 or 6 states, Jeb Bush didn't make 1%. Okay. So the media went crazy and they said, okay, we got to have another person. Jeb Bush is not going to be it, and we can't let Trump be it. So what are we going to do? So they got Ted Cruz. And before the second debate or third debate, there was this poll that came out. And it was just out of nowhere. Nobody has seen this poll before. And guess what it said? It said that Ted Cruz was leading the polls and going to be the presidential nominee for 2016, the Republican presidential nominee for 2016. And this poll had a plus or minus margin of error of 7%. And in, okay, let me rewrite that. Margin of error equals 7%. And in was equal to like 1,000. Can somebody tell me what's wrong with this? Okay, no, I guess not. First of all, anything over 3% is not really a good measure. Anything over 3%, you really take with a grain of salt. This was supposed to be a national poll. What's wrong with national poll and N is equal to 1,000? We have over 325 million people in the United States. And they go out and they ask 1,000 people? No. What was this called? This was called, you could call it a subjective poll. You could call it an oppressive poll. I don't care what you call it. What was this poll trying to do? It was trying to lead people to start supporting another candidate. Okay, now I'm not the one that's saying this. I agree with it, but there were several people on the news saying this poll, where did this poll come from? And they were saying that it was trying to get people to leave Jeb Bush and start supporting Cruz. I don't know if some of y'all remembered that, but you'd have to actually watch the news to see something like that. And most people don't watch the news. They just drink the Kool-Aid. All right. So this is what happens. All right. You get subjective polling. Personally, you know what I think they should do before every election? I think they should burn every poll. I don't think polls should be even before an election. I don't think they should be advertised, period, because it affects the way people think. And I just really don't think polls are good before any election. I don't mind people, doing a poll a year before the election. That's fine. But I think it should be 6 months before the election. I don't think there should be a single poll anywhere. But that gets into free speech, and you can't do that. But anyway, that's just my own opinion, and I got an opinion like everybody else. As long as it seems, I'm all right. So anyway, and that was in the past, so y'all can't complain to me about me talking about elections because I talked about the past election. Okay? And that was among the Republican nominees, not between the Democrat and Republican people. Okay? All right. So that's how we talk about bias. And bias, and I don't know why they're taking so long to talk about bias, but that's what they're leading up to. Charts and graph. What's wrong with this? What's wrong with this? You ain't got to look at any of this. Just look at these two squares. Somebody tell me what the problem with these squares are.
One's bigger than the other?
Yeah, you're getting there. Keep going. What's wrong with it? How
More
many?
money in one than the other?
No. How much? What is the difference in the numerical data? It's double, right? How
Yes.
big is the green square compared to the orange square?
Twice as big.
Say again?
Is it well, it's not twice as big, but
It's how many? How many of those orange squares could you put in this
4.
green square? 4. So the square is 4 times as big as the orange square, but the data is only double. They do this all the time in magazines and newspapers. You got to watch for this. Same thing here.
So what does that mean?
That means that this is not right. The data is double, but the picture is misleading. The data is double, but the picture is misleading. The picture should only be but it makes it look like what? When you look at that, it makes it look like this is 4 times more than this. Same thing with a cube. Look at there. You could fit 6 of these in here. 5 or 6. This square, this cube is 4 to 5 times bigger than this cube. Here's where they really get it wrong, right here. What do you always check for on a graph? I mean a pie graph. All of them should equal what?
100.
100. Well, heck, I know that ain't right, because look at here. 50 and 42, that's 92. That's not 100%. This is way over 100%. So a pie graph is useless unless it equals 100%. Y'all remember my bonus question about homework, test, how much they're weighed? 30, 30, 30 doesn't equal what? 100%. Everything must equal 100% if it's in percentages. So this is misleading. And I guess we're not going to talk about bias. It must be in the next section. All right, we're going to shut her down. You should be able to work on 12.1 homework now. I've already done the attendance. So, Mr. Brown, I included you on Wednesday because I knew you'd show up today. So everybody's here, and all y'all need to do is work on 12.1 homework this weekend, and I would suggest reading 12.2 before Monday, okay?
have a nice weekend.
Okay, thank you. Y'all have a nice weekend too. See y'all.
See ya.
See ya.